Hey guys, today we're going to go over the AP Statistics Free Response Question 3 from the 2019 AP Statistics exam. You can access these questions on the URL that's posted here, or you can Google AP Stats exam and find the posted questions there as well. So in 2019, question 3 read, a medical researcher surveyed a large group of men and women about whether they take medicine as prescribed. The responses were categorized as never, sometimes, or always. The relative frequency of each category is shown in the table. So we're going to go over the correct answers and also talk a little bit about scoring and how to maximize your score on this particular question on the 2019 AP exam. So let's look at Part A. Part A is scored all together. Part A, I, and I. And so this is one person from those surveyed will be selected at random. So let's look at Part I. Part I, what is the probability that the person selected will be someone whose response is never and who is a woman? So this is an intersection. So we're looking at the probability that they respond never and intersection that they are a woman. So looking at our two-way table, we want them to respond never and we want them to be a woman that responds never. So we're looking at the overlap of those two column and rows. So this is 0.0636. Part II, we're looking what is the probability that a person selected will be someone whose response is never, or, so this is a union, who is a woman. So remember our formula for unions, the probability of never or a woman is the probability of never plus the probability they are a woman minus the probability of overlap, never and woman. So if we look at the two-way table, the total probability of them answering never is 0.12. The total probability that the person surveyed, I couldn't see the table there, as a woman is 0.53. And then from Part AI, we found out the probability that they are never and a woman is the 0.0636. So when we subtract that, we get 0.5864. Now, if we look back at both of these, Part I and II, be very careful here. We have not proven that the probability of never and the probability of being a woman, we have not proven that those are independent events. So make sure that we are not calculating the probability of never and a woman. We're not saying it's the probability of never times the probability of a woman. We can only use that calculation if we've proven that the two events are independent, and we have not done that yet. So up until now, we're reading all of these probabilities directly from our two-way table. All right, the last part here is I. So this is the probability that a person selected will be someone whose response is never, given that that person is a woman. Remember our formula for given, it's the probability of the and, never and woman, divided by the given, which is the probability that they are a woman. Or we can also look at this from our two-way table. Given that they're a woman means we're only going to look at that particular line of our two-way table. So the probability that they answer never and they're a woman is this value, 0.0636. But instead of dividing by our total of 1, we're dividing by this given category, the probability that that person is a woman, which is 0.53. When we divide, we get 0.12. So this score, question 3, is scored, has 3 parts. Part A for the score is all of AI, AII, and AII, making sure that you have 3 correct probabilities to get an E, and making sure in your work that you have calculated these probabilities for intersection from your two-way table, not by multiplying the probabilities of the separate events, since we do not have any way up till now of saying that those are independent events. Now let's take a look at Part B, which is scored by itself. 3, Part B. For the people surveyed, are the events of being a person whose response is never and being a woman independent? Justify your answer. So there's a couple of ways that we can justify this answer. If we can show the probability that you respond never and you're a woman, that intersection probability is equal to the probability of never times the probability of being a woman, we can prove independence. Well, we can get the probability of never and a woman from our two-way table, 0.0636. The probability that you respond never is 0.12. The probability that you are a woman is 0.53. And then we can do the calculation showing that the two sides of this equation are equal. Now, that alone is not enough to get you the correct score. That's one piece that you need to get your E on this part of the question. You also have to make sure that you draw a conclusion. So we could say, for example, since the probability of never and a woman is equal to the probability of never times the probability of being a woman, the events, answers never and woman are independent. To get all three parts for an E, we must conclude that they are independent. We must show our calculations to prove these values, and then we have to show our justification or our proof. The other way we could do this is we proved earlier, we could say the probability of answering never given that you're a woman is simply just equal to the probability that you answer never. In other words, knowing whether you're a woman or not did not change the probabilities. Again, we have to prove this to prove independence. So we can grab this from part A, and that was 0.12. We got that calculation earlier. And then the probability of never was 0.12. And so we can say, since the probability of never given a woman is equal to the probability of never, then, and we can go ahead and answer the events, answering never and being a woman are independent. We're going to want to make sure we show this work here. If you've already showed it in part I, you're probably okay, but I would be very careful to actually show this calculation again on the left side of that equation. All right, last but not least is part C. Assume that in a large population, the probability that a person will always take medicine as prescribed is 0.54. So the probability that they take as prescribed is 0.54. If 5 people are selected at random from the population, what is the probability at least 4 of the people selected will always take the medicine as prescribed? So we're talking here about a fixed number of trials, 5 people, a probability of success, in this case that they took medicine as prescribed. So we're looking at a binomial distribution. You do have to identify either by name or formula that you're dealing with a binomial distribution. Remember, your binomial distribution has your N value, your set number of trials, which is 5, and your probability of success, which is 0.54. So that's one piece of the score that you're looking for. Now, when we talk about a random variable x, we're going to let x equal the number of people taking the medicine as prescribed. We need to show our boundary in our probability statement. So we're looking at the probability that the number of people that take the medicine as prescribed is at least 4, so greater than or equal to 4. So that's our boundary value and direction. Now we can calculate this. This is literally the probability that x equals 4 plus the probability that x equals 5. But we can also calculate this with our calculator. This is a binomial CDF. Our lower bound of 4 and our upper bound of 5, so 0.2415. You do need to name binomial with the parameters. You need to show your boundary and direction. You can either get that here or here, and you do need to show the correct answer. The other thing you could do is you could also write that this is the probability that x is greater than or equal to 4. You could actually write that as your separate probabilities. This is 5, choose 4. 0.54 to the 4th power, there are 4 successes, times 0.46 to the 1 power, plus the probability of 5, choose 5, 0.54 to the 5th, 0.46 to the 0 power. And if you show that whole formula, you can get credit for showing by formula that this is a binomial distribution. Alrighty, I hope this was helpful. Good luck as you work through the rest of your review questions for your AP exam.